next is basic nature of amines. Now students, whenever we consider basic nature, again the responsible factor is the presence of lone pair of electrons. The presence of lone pair of electrons on nitrogen. Nitrogen in amines uh, can be easily donated, and hence as a result it acts as Lewis base. Now the responsible factor for basicity has to be the presence of lone pair. So the availability of lone pair more, basicity will also increases. Anyway, the presence of lone pair and thus acts as both basic as well as nucleophilic property. So it is found that nitrogen, the presence of nitrogen, the lone pair on nitrogen, basicity increases, and hence we see the next class of compounds. Example, we have the reaction with mineral acids. If you take an amines RNH2, RNH2, consider a primary amine is treated with halo acids, and amines being basic in nature is able to donate its lone pair, so it undergoes protonation, resulting in the formation of the corresponding salt will give you RNH2. Since nitrogen has donated its lone pair, therefore it will carry positive charge, so that NH2 will become NH3 plus and X minus, so that will give you alkyl ammonium halide. So alkyl ammonium halide. So in short, it will become NH2 will become now NH3 plus. So NH3 plus, that is called as alkyl ammonium halide, and the presence of lone pair was a responsible factor in the corresponding salt. So being basic, all types of amines reacts with mineral acids to form the soluble salts, and how thus amines are basic in nature. Now it acts as Lewis base as it donates its lone pair of electrons. On the contrary, it also acts as a Bronsted base. Bronsted base, according to Laurie-Bronsted theory, as it accepts a proton from acids. So Bronsted base, or it can act as a Lewis base as it donates a lone pair of electrons. The next is an example. If you take ethylamine, formula is C2H5 dash NH2. Ethylamine, you treat it with HCl. Nitrogen has lone pair of electrons, can be donated, resulting in the formation of RNH2, RNH2 and H. It's nothing but RNH3 plus and Cl minus. So that results in the formation of R, we took it as C2H5. So C2H5, so what we called as C2H5, I'll repeat, C2H5 dash NH2 ethylamine plus HCl will give you C2H5 and NH3 plus and Cl minus. So that will give rise to ethyl. NH3 plus will give you ammonium, so ethyl ammonium chloride. Nitrogen carrying positive charge, remember students, ammonium, so ethyl ammonium chloride. Similarly, aniline is benzene with NH2 plus HCl will result in the formation of donation of lone pair, resulting in the formation of NH2 will become NH3 plus and Cl minus. We call it as phenyl ammonium chloride. Can also be called as, since it is derived from aniline, so can also be called as anilinium chloride. So acid plus base will result in the formation of the corresponding salts. Ethylamines, similar example, can also be taken with H2SO4. H2SO4 is an example of a dibasic acid. It can definitely donate its lone pair. So this will give rise to C2H5, NH2, C2H5. This is 2 moles. This will give you C2H5, NH2 will become NH3 plus and SO4 minus 2. So ethylamine plus sulfuric acid gives ethyl ammonium sulfate. Sulfuric acid is a dibasic acid, so it will consume 2 moles of ethylamine. 2 moles of ethylamine. I repeat, it will consume 2 moles of ethylamine, resulting in the formation of ethyl ammonium sulfate.